Alright guys, suppose the following, that we have 1, 2, 3, 4 warehouses, and also that we're having 1, 2, and 3 factories. And let us assume that our warehouses are destinations from which we have to send goods from these sources, from these factories. Let us also assume that every warehouse from these 4 are having different demand levels of goods, so number of units they are demanding, here represented by the size of these red bars. That could represent high demand, low demand, in the middle demand, in the middle demand. And just like they have different demand levels, we also have different capacity levels from the factory. So some factories can produce more than others. That's life, that's how it is. Okay, so we're not over yet. So if we have to send goods from sources to destinations, we can do something like this. For example, from factory 1, we can ship goods to any warehouse that we want. But of course, it comes at expense. Yes, because these letters, these constants, represent the total cost per unit, and the number of units are represented by this variable x. You see? So we have a certain number of units, and every unit will cost you a certain amount. Let's just keep this as variables, okay? And just like we did with factory 1, we can have the same story for factory 2. And guess what? You are absolutely right, the same story from factory 3. So let us stop here for a second. What we're having here is a network. It's a network in which factories can supply goods to destinations, but of course there is a combination of cost, and this cost will depend on the cost per unit, depending on the combination of factory warehouse, and also on the volume that we are shipping. So the question that we are trying to answer is, how can we fulfill this demand with the minimum cost? So how can we find that sweet spot, that nice combination of amount of goods that can be shipped to every place from a certain source? If we want to translate this, what I just verbally described, into a mathematical equation, it will look like this. The total cost is the sum of all these costs, because this multiplication of x and c, x1 and c1, is the total cost of sending goods from factory 1 to warehouse 1, right? That is the cost per unit, and these are the number of units. So if that costs €1 and we are sending 10, what is the total cost? 10 times 1. You are absolutely right. And you see, we have to add everything. It could be the case that we might also have zeros, like we don't ship anything, because we can fulfill the demand from a certain warehouse from just some other factories. So there are many combinations here, but the goal is to minimize that cost, and that means finding the right combination of x, volumes that are shipped from one point to the other. Okay, so letter C is a constant. These are transportation costs. We cannot manipulate this, but we can play with letter X, because X is a variable, are the volumes to be shipped. Once again, keep in mind, we have constraints. These places, they have different demand levels. They also have, factories have also different capacity levels. So in practice, it means maybe you have a high demand on warehouse 1 that cannot be completed or fulfilled only by using factory 1. That means that you need another factory to do that job, to help that factory. So this is what it means. Okay, so this, what I just described, is the transportation problem. That's the name of it. You can Google that. You can watch tons of YouTube videos about this. And this topic belongs to module 3, location decision, because it's about locating a facility within a supply chain network. Okay, so the way we're going to tackle this is by framing this as the transportation problem. And the way we frame it is in the following. First, we're going to assume that we have a balance system. Balance system means demand and supply are equally the same. This is the starting point for any kind of technique. So this is the easiest. So we have a list of warehouses, destinations. with their respective demand levels, altogether 60 tons, and these are the same tons that we can produce by these factories by different capacity levels. So this is balance. This is our starting point. Then we're going to follow this method. There are 3 steps. Then step 1 is to create a row for each plant and a column for each warehouse. This is what you see here. Here we have our factories with their respective capacity levels. And here on the bottom we have our warehouses with their respective demand levels. And all this is what for some reason authors from different books call tableau, which is I think a French word, at least it sounds to me. And because French resembles Spanish, it sounds like tabla, which in English would be table. Yeah, so you see all these words, they look alike. So I don't know why they don't call it the table, but okay, I guess tableau sounds better. So we create this table, and you notice that it's partially completed because here in the center we have empty cells. These cells are the ones to be used for the transportation cost. Remember, depending on the combinations that we have, because we can send from a specific factory to a specific warehouse, we might have different costs. So here they are in red. The red numbers are cost. Cost can be not only money, can be time, like manpower, personnel, resources, materials. It could be any of those. So now our tableau is ready, is completed. And now the job that we have to do is to decide which from these products have to be shipped to these destinations, but of course at the expense of this cost. And we want to have a nice combination that minimizes this total cost. So for that purpose, there are many different algorithms, like recipes that we can follow. And of course, nowadays we have very powerful computers. We can just run with an Excel solver. We can run a linear programming kind of solution solver and get that result. But we're not going to do that. We're going to do it in the old-fashioned way, which is by hand, manually. And this gives you a suboptimal result. Suboptimal means it's a first cut, it's a starting point. Is this useful? Yes, it is, because it helps you to create right away a feasible solution. You can try it at home, do your own allocation, and you will see that it's not that simple. You will break a lot of the constraints given, like sending more products from a factory that cannot produce so much, for instance. So we're going to follow these two. I know that they have kind of funny names. There's a reason for that, and you will see why. So let us start with the northwest corner. Okay, so northwest corner method. We have here our tableau, and this is how it works. So suddenly you see a number 10 appearing here. That means that we are sending from factory 1, that has a capacity of 20, we are sending 10 products to warehouse 1. Why 10 products? Because warehouse 1 demands 10, no more than that. So we can scratch 10 out of our factory, and that means that we have still a remaining of 10, and we can forget about warehouse 1 because its demand is being fulfilled, is completed. We can do the same. Now we are sending 10 goods, 10 tons to warehouse 2. All right, but that is not enough because warehouse 2 demands 15. So what happens now? Well, we still have 5 remaining. So let us stop here for a second. So what you see here is the allocation of number of goods shipped from factory 1 to warehouse 1 and warehouse 2 at this expense. These are the costs. Okay, so let us continue. Factory 1 is depleted. So we move to factory 2. And that's why I scratched this 25, because we are sending 5 to fulfill the remaining 5 from warehouse 2. Yeah, so that means we still have 20 in factory 2, which can be used for the 15 that are demanded on warehouse 3, remaining 5 from that factory and having warehouse 3 completely fulfilled. And lastly, we have the last 5 from factory 3. We just sent everything to warehouse 4. Obviously, that is not enough. We have 15, and that matches perfectly to what we have from factory 3, because this is a balanced system. Okay, so boom, gone. And what we have here is the allocation of factory warehouse. These are the allocations. These are the solution, so to say. But we still need to calculate the total cost. So how do we do that? We do it like this. Total cost is basically the number of units sent times the cost per unit. So 10 times 10, that's here. 10 times 0, that's that. 5 times 7, and the rest the same. So you see where these numbers are coming from. And when we add all these up, these are the total cost for this allocation. 640 could be 640,000 euros, for instance. Can we improve this? And then you would say, yeah, of course. And then I would say, how? How would you proceed? And then you would say, well, I will prioritize the combinations with the lowest cost. Look, so if it's for free basically to send goods from factory 3 to warehouse 1, why are we sending from factory 1? Let's just send them from factory 3. That you're absolutely right. And you know, that is actually your method is good. It's just that you were not the creator of that method, I have to say. Sorry for that, because that is the least cost method. And that's basically how it works. So we start prioritizing based on the lowest cost to the highest. So here we send 15 right away. It gets fulfilled. We have 5 remaining. And then we forget about that because now we are sending 10 for fulfilling warehouse 1. And so far we have fulfilled 2 warehouses at the expense of 0 based on this allocation. Now we continue. We move now to the 9 because it's the next one. We just have 2 more warehouses. So then we send 15. We have a remaining of 10. And, sorry, here, let me go back. I went too fast. So now we have only 20 remaining from warehouse 4. And these are the remains from our 3 factories that we can simply shift all the way to warehouse 4. And that's the reason why these lines were like this. And then it looks like this. That's the allocation. And then done. Good job. So now we can calculate our equation. And this is how it looks. We have here our zeros. 15 times 9. 5 times 11, 20 times 10, 11 times 5. And now the total cost is 480,000. Look, what a dramatic change. Do you remember? It was before 620. So we drop it to 480. Here's the question. Can you still improve this? And maybe now it looks a bit tricky, no? Because you say, hey, I just prioritize lowest cost. And this is a moment in which you can rely on Excel solver, and you can do this just for fun at home. I don't expect you that you master this technique, but you can also do it. And when you do that, you can still reach to a lower result by means of this allocation, the one you see here. So that's it. So we have this allocation, and this was done by linear programming, basically, which of course you can also do by hand if you want to learn that. But I think if you manage to do this even by using Excel, it's a big success. It's not for your exam, it's for your life maybe, but it's a big success. So you can find tutorials on YouTube. So this is the simplex method, and this we drop still $20,000 further. Okay, so 3 methods from which you need to learn 2, northwest corner and the least cost method. So all in all, of course, these methods have some considerations and assumptions. First of all, both sources and destinations, they have fixed capacity and demand levels. We know that that is not the case. Demand fluctuates through time. Sometimes it's uncertain. Same with the capacity level of factories. Costs remain constant. Also not the case. Diesel prices are changing every day. Destinations are accessible. Not always. Only one commodity. Well, yeah, sometimes you send a truck with more than just one. And one destination can receive its demand from more than one source. It is not always the case. Sometimes you have constraints in these connections. You cannot send from a certain factory to another destination. This combination might not work due to tariffs or countries. Who knows? But we forget about all that. It's just important for you to know these assumptions. Okay, so you have a homework exercise. I'm not going to read this for you. You have to read it. You can pause this video. You're supposed to use the least cost method. Here's a bit of a story with even some examples on how to interpret the data that is also provided to you. And I can also show you that. And it looks like this. So, sorry about that. And it looks like this. We have destinations. We have sources with their respective capacities and demand. And here, in these tiny boxes, we have our cost function. So your job is to identify what is the best combination by following the least cost method. So allocate from capacity to destination and calculate the total cost. You do that, you send me your results, and I can tell you whether you were right or wrong. How about that? That's it for now. Thanks a lot for your attention. I hope that you are doing well, staying healthy, and we stay in touch. Bye-bye.